Today we are going to present a paper on the task scheduling of high dynamic edge clusters in satellite edge computing. This paper was presented in 18 to 23rd October 2020 IA World Congress on Services. The paper was written by Jirong Han, Haopeng Wang, Sajong Wu, Zibong Yu, Li Yan. The details of the document to the paper, the link has been given in this slide. The main aim of the paper is to address the problem in communication in traditional satellite information processing mode. What generally happens, the satellite information networks only provide data transmission support. The satellite transmits the collected data to the ground data center for processing through the satellite ground link, and then the data center uploads the results of the calculation to the satellite or other ground users. The main disadvantage of this particular process is that there is a lot of wastage in the satellite resources in this. Why these wastages are there? If we can refer the paper, there is a huge cost of bandwidth resources is caused during the transmission of data generated by satellite big data applications such as remote sensing, meteorological and resource observatory services, which brings about a problem that the time-sensitive tasks are not responded instantaneously. The other problem is that the computing and storage resources of satellite information network are not fully utilized in this point. So what is the solution to this problem? The paper proposed the mobile edge computing into the satellite network to realize the information processing of the satellite environment. In this computing mode, the data collected by satellite sensors can be processed in real time at the edge, which avoids the tedious data transmission process between the satellite and the ground, which saves bandwidth resources and realizes rapid task response. In this mode, other users in space or on the ground can obtain computing power support of high performance, low latency, high bandwidth between satellite network through wireless access. What is the core of this paper? The core of this paper is the algorithm SDPLS. This classical algorithm faked on the fact that it proposed a delay optimization scheduling algorithm based on the dynamic parity queue, and that's why it realizes its name satellite-based dynamic parity queues. The algorithm can adapt to the particularity of satellite scenarios, optimizes the application completion time in a dynamic network environment, and realizes the efficient use of satellite mobile computing clusters resources. The main idea of STPLS is to dynamically adjust the priority ordering of the task according to the real-time network status, so as to obtain the task with the highest priority under the influence of network conditions and select appropriate processes or satellite modes for processing. However, there are few drawbacks with the SDPLS algorithm. The validity of the result is tightly coupled with the accuracy of the network environment description. Also, the characterization of satellite network environment is not accurate because there can be multiple other sub-satellites, child satellites, and other network-related issues are not incurred in this. SDPLS has the best performance, while there are other algorithms like MPFT which has a better acceleration performance when the number of processors is small, and then other algorithms which are MHEFT, MB, SPATS when the number of processors is large. So what is the scope of the environment improvement in this particular paper? The right now experiment results shows that this algorithm can better adapt to the dynamic nature of social satellite network environment, which effectively shortens the application completion time and realizes the efficient utilization of satellite resources and rapid task response. But the characterization of satellite network environment is not accurate enough, as we see that in the case of small processors or large processors, the performance accelerates or decelerates. Therefore, the scope of conducting in-depth research is the further improvement area in the adaptability of this particular algorithm. Thank you very much for taking your time to go through this presentation. I really appreciate this humble gesture.